seekers after truth. It's a great honour to be here. I'm very grateful in particular to Peter Tillett for having given me the chance to be here, to hear so many of you, meet so many of you. My subject for today is to raise the question, is CO2 mitigation cost effective? And here I am for the first time trying to marry climate science in one direction and economics in another, without being either a climate scientist or an economist. Hitherto, the literature has chiefly addressed the cost effectiveness of climate mitigation globally. But the aim here is to assess the cost effectiveness of climate policies down to the individual policy by a scientifically robust, yet simple enough method to allow even non-specialists to determine, at least to a ballpark, the cost effectiveness of any CO2 mitigation policy down to national, local or even individual level. And to do this not only against competing policies, but also against the cost of the climate-related damage that might occur if CO2 emissions were not mitigated at all. The method is to determine, by a series of very simple, deliberately simple equations, the cost of taking no action to address global warming, how much global warming will be abated by any given CO2 mitigation policy, and then, under the assumption that the global cost effectiveness of all mitigation strategies is equivalent to that of the policy under consideration, that policy's CO2 mitigation cost effectiveness, the global abatement cost of warming from all forcings over a projected global warming up to a target year, and then also to answer the question by how much the policy costs more than the cost of doing nothing, or less if you're lucky. Now the first question that ought to be asked in this subject is what discount to present value we are going to use. And a brief discussion of this is necessary. Present value is the value to us of future dollars at today's prices. And the bird in the hand rule is that a dollar today is worth more to us than a dollar 100 years hence. And the discount rate reflects that. Now here is Stern's account. This is from Sir Nicholas Stern's report, now Lord Stern, published in 2006. Still perhaps the most detailed assessment of how much it would cost us if we did nothing to try to mitigate global warming. Now, it is normally the rule that when you're putting up a discount rate to do an intertemporal or intergenerational comparison, then you always state what your discount rate is up front. This particular paragraph, which does not state explicitly that this is the discount rate that Stern is taking as his central rate, appears on page 161 of his report. And it took me 3 weeks after his report was published to get his office to admit that it is this that is his central discount rate. And it appears to be based on a misreading of the literature. It's now criticised by implication even on HM Treasury's own website. He's using a discount rate of 0.1%, which is just about the lowest discount rate I've ever seen used in this kind of context. Now, the market discount rate is simply the rate of return on capital. Broadly speaking, that's going to be the appropriate rate. And Václav Klaus at a conference in Cambridge that I hope to organise earlier this year, the President of the Czech Republic, a formidable free market economist, says that by assuming the very near zero discount rate that proponents of the global warming doctrine, such as Stern, use, they neglect the issue of time and of alternative opportunities. Using a low discount rate in global warming models means harming current generations vis-à-vis future generations. And he also makes the point, a very important one, that undermining current economic development also harms future generations. So he argues for an absolute minimum discount rate of 5%. And it is that rate, the lowest real rate of return on capital that a businessman would normally accept, that I'm proposing to use today. But we shall not be forgetting Stern's discount rate, we will come back to it. So we now evaluate the cost of doing nothing. And I'm going to take as my starting point Stern's report. He is generally criticised in the literature for having greatly exaggerated the cost of the damage that might arise from global warming. But I am not going to make any reductions in his estimates of how much damage might arise The only adjustment I am going to make is to the discount rate that he uses over the next 100 years. I use a standard economic formula to convert the costs of inaction based on his discount rate to the cost of inaction based on a 5% discount rate. Now he says that if there is a 3 degrees Celsius warming over this century, which is broadly speaking the IPCC's central ballpark estimate, then he says that will translate into a cost of inaction of 3% of global GDP. He says if, as he expects, we see temperatures of more like 5 or 6 Celsius above days, then that goes up to 5 to 20% of GDP. But if we correct for the change in the discount rate, then those respective values for the cost of inaction fall to 0.2, 0.4 and 1.5% of GDP respectively. In other words, using the market discount rate rather than Stern's discount rate approximately reduces the already not particularly big costs, particularly if the warming isn't any greater than that with IPCC, by about an order of magnitude. And here you can see several of the discount rates that have been used by various people. Stern, the lowest one there at the top, 0.1%, and then going down via Ross Garnaut for the Australian government to the 2 climate change rates used by HM Treasury and the HM Treasury standard green book rate that I used to use when I did these appraisals at 10 Downing Street, and then the market rate there at the bottom. And I've also marked off the 8.7, 4.1% cost on the right there, inaction cost of maximal damage, because Garnaut uses a figure of 6% of GDP as the maximum cost of inaction over the 21st century, based on his interest. His discount rate is 1.35 to 2.65%. And as you can see, that indicates that, broadly speaking, the method I've used has put the numbers in roughly the right ballpark. Well, now, as this is economics, there's of course going to be a series of assumptions, and they're going to be simplifying assumptions because I only have 20 minutes. First of all, costs external to the cost of the policy itself are excluded. Likewise, benefits external to mitigation of CO2 forcing are also excluded. GDP growth rates and welfare losses from climate inaction are assumed uniform from now until the end of the century. And above all, the IPCC's climatology, in particular its central estimates on how much global warming we are going to get this century, are going to be accepted for the purposes of this argument from here on, said Solon and fundamental. So, turning then briefly to the IPCC climatology, the 2 particular things we need to know before we start doing calculations of individual policies is what is the transient climate sensitivity parameter for the 21st century in Kelvin per watt per square metre. And you can derive this from each of the individual SRES scenarios that you just heard Dr. Garrett talking about. And the other thing we need to know is what percentage of all forcings does the IPCC imagine CO2 to be. That again can be derived from each of the individual scenarios. It's about 7%. So I'm going to take as a case study to illustrate this method Australia's CO2 tax. Now, the target final year of the policy, this is their target, is 2020, so we'll give it 10 years. The percentage of national emissions that is intended to be abated by this policy is 5%, and Australia's percentage of global emissions is 1.2%. And that gives you the fraction of global emissions abated, if the policy were to succeed exactly as the Australian government intends, is 0.06%. Very, very small, and you begin to see now where this is going to go. We also need to know what the projected CO2 concentration on a business as usual case would be by 2020. That's 412 parts per million by volume, taken from the IPCC's A2 scenario. Global annual GDP in 2010 was 60 trillion, growing according to the Bank of England's advice, which I took from one of their monthly policy criteria, 3% a year. Australia is also going to have a cost escalator above GDP growth of 2% for its climate policy, so we add that in. And that gives us the cost to 2020, discounted to present value at 5%, of simply 130 billion, or 10 years and 13 billion. We also need to know what global GDP over the period is expected to be. Once again, growing at 3% a year, discounted at 539 trillion. Those are the assumptions we put in, the parameters, if you like. So the first thing we need to know is how much global warming will the policy abate? And this is simply a function of the amount of warming that would, the amount of carbon dioxide concentration that would have obtained in the absence of the policy, and of course the amount that would obtain if the policy is fully effective. And so the equation there simply sets that out using the Myrie et al. CO2 forcing function and the climate sensitivity parameter of the 21st century we've already seen from the IPCC. And that means that this policy, if fully implemented and fully successful as the Australian government intends, will forestall 0.00085 Kelvin of global warming over the period. That's less than 1/11,000th of a Celsius degree, and it's less than 1/500th of the minimum threshold below which no modern instrument or method can determine whether there has been a change in global temperature. So even if this policy were to be full, they will have no way of measuring that it has. Now the reason why you get such very small changes in global temperature as a result of such policies is of course that you get only a very small change, you can see that highlighted at the bottom there, in the CO2 concentration, and that in turn is caused by the fact that only a very, very tiny fraction of global emissions is affected by the policy. Now you may say, this is a little unfair, just to take one example and then say, well, that's not going to make any difference, it's only if we all pull together that we get anywhere. So for that purpose, we use a concept widely used in economics generally, but not so far really mentioned at all in literature in connection with the climate, and that is mitigation cost effectiveness. And I'm defining this, since nobody else seems to have defined it, as the cost of abating 1 Kelvin of CO2-driven warming by policies as cost effective, or depending on the point of view, ineffective, as the policy under consideration. And that is simply the gross cost of the policy divided by the amount of warming forestalled, and that gives you the mitigation cost effectiveness in dollars per Kelvin forestalled. And as you'll see, it's 1.5 quadrillion dollars per Kelvin forestalled on the basis of Australia's policy. Then we need to know what is the cost of abating all the warming that is predicted to occur on business as usual over the term that the policy is expected to operate for. And here again you see some quite large figures. You've got £318 trillion cash as the cost of installing the 0.15 Kelvin of warming that the IPCC would expect to see between 2010 and 2020. That's around $45,500 per head of global population, and something like 59% of global GDP over the period. So very large numbers are coming out, and this would be what would come out if everybody did the same policy as, or at least the policy as cost effective as the Australian. So then, finally, we need to know, is this more or less expensive than doing nothing, sitting back, enjoying the sunshine and watching the trees grow a bit faster, the ones that aren't dying? And here we simply take the GDP cost of the policy there, 59% of GDP, in forestalling all the global warming period, and we divide that by Stern's 0.22% of GDP. Remember, we've adjusted the 3% of GDP down to 0.22 by correcting the discount rate, and that means that it's actually 266 times more expensive to make global warming go away using methods as cost effective as those now being implemented in Australia. And if we look at that for various discount rates, rather than just taking the discount rate that I have recommended, which is the market rate, then you see that what is happening is that even under Stern's 0.1% discount rate, at the sort of warming that we're expected to see, 3 Celsius of GDP under the IPCC's estimates, it's still around an order of magnitude more expensive to act than not to act. And so there is a summary of the figures we've just looked at. All these slides will be available later. And so now we're going to compare this with a few other policies that have been implemented. Here is the US CO2 emissions trading bill. It failed in Congress, largely because people could see it wasn't going to be cost effective. Even this, which was very optimistic, was going to be at least double the cost of doing nothing, and at the sort of warming that we expect to see here in the 3 Celsius, around 10 to 15 times more expensive to act than not to act. The Canadian coal power regulations, just adumbrated by the Conservative government there, something similar. The UK Climate Change Act, and all these are predictions, rather optimistic ones, of how much warming will be forestalled and at how little cost. And you see, even these are an order of magnitude more expensive than doing nothing. If we look at some actual real-world policies that have been put into effect, rather than taking mere governmental predictions, we see how much greater the costs are actually proving to be. EU CO2 emissions trading here, around an order of magnitude, 2 orders of magnitude more expensive to act that way than to take and pay for all the damage of doing nothing. The world's largest wind farm at Thanet, about the same, a $2 billion subsidy for one wind farm over the next 20 years, guaranteed by the poor British taxpayers. And then we could look at what I'm going to call gesture policies. First of all, Maryland is proposing to cut CO2 emissions by 90% by 2050. And that's 3 orders of magnitude more expensive than doing nothing. A single small windmill on your house, as a school in England has recently done, again, 3 orders of magnitude more expensive. And the silliest scheme I've found yet is the London bicycle hire scheme, which has introduced bicycles to the streets of London at a cost of $26,000 per bicycle, and that would be something like 20,000 times more expensive to act than not to act. So the conclusions from this then are that really CO2 mitigation on this analysis is not in any way cost effective. We're much better off doing nothing, and a warning that in fact the policies that we're looking at are likely to be much less cost effective even than these figures have shown. In particular, if CO2 residence time is about 125 years, the IPCC says it is, then you're not going to get much CO2 mitigation this century either. So finally, no policy to abate global warming by taxing, trading, regulating, reducing or replacing greenhouse gas emissions will prove cost effective solely on grounds of the welfare benefit from climate mitigation. Strategies that are inexpensive enough to be affordable will be ineffective. Strategies costly enough to be effective will be unaffordable. Focused adaptation is the way to go. As we say on the London insurance market, the cost of the premium exceeds the cost of the risk, so don't insure. We have no more chance of altering the climate by these measures in a cost-effective way than King Canute had. So to him goes the last word. Thank you.
Questions? Yeah, Steve Schwartz, I'll step into the fray. It sounds to me as if you're suggesting that rather than spending our monies for any CO2 abatement, we should all take vacations in Palma and let our grandchildren suffer.
That's a very fair question, or rather it's a very unfair question. The point is that what I'm saying is that even if you try to spend lots of money on making global warming go away, on stopping the sea level from rising,